Hey there! So already you should know quite a lot about Data Factory, and probably you even started creating your own pipelines. The thing is that those pipelines, well, they will fail from time to time, either because of the bugs you introduced, or simply because we are implementing it in a cloud environment. And it is a cloud's nature to expect some transient temporary issues. For example, the resource to which you are trying to connect might have some issues and it might be not available for a minute or so. But if you retry the attempt to connect in 5 minutes, it will work. So simply it means that error handling and monitoring is quite important in Data Factory. And that's the topic for today. So let's get started. Alright, so error handling. Let's start writing it down. So error handling in ADF, obviously. So it's ADF, error handling. And actually, I will talk not only about error handling, but also about monitoring. How to monitor our pipelines. Monitoring. All right. So the first thing we could do out of many in this area is basically retrying our operations. So set retry option. And how does it look like? So let's jump into Data Factory and let's create some new pipeline, a dummy one. And let's use one of the activities that we'll use the most often, a copy data activity, which, as you should already know, is able to connect to a variety of data sources, grab the data, and just save it somewhere, again in a variety of sinks, target locations. And we did it already when we were ingesting data from Azure SQL database and dumping it as CSV files into a data lake. And now, one of the properties that are available in many activities, including the copy data one, is this retry section, which means that we can very easily ask Data Factory to retry given activity if it fails. And all we have to do is to set a value to a number that works in our case, and set an interval. So that's the pause between consecutive retry attempts. And that's it. It's as easy as it looks. So basically, right now, Data Factory will try to copy data according to the configuration we did. If it fails, it will wait. It will wait for 30 seconds and then try it one more time, and it will repeat this process 3 times. And if the issue that we are facing was a temporary one, maybe a SQL database was not available for some reason, but maybe the next time we try to connect, it will work. So that's the bare minimum you should do when you think about error handling. And basically, this pair of configuration options, retry and retry interval, it is available in case of many activities. So if there is such capability, please use it. That's the bare minimum. Now, the thing is that if you have a bug in your code, your pipeline, well, it has some issue, not related to the connectivity to the source or target, then obviously retrying the attempt to connect, obviously it won't work because the bug is still there. So how to handle this? Well, let's jump into the whiteboard and let me add a new thing that we could do. So apart from retrying the operations, we have something called conditional paths. Conditional paths. And we've got Actually, let me show you that in action. So let me remove the copy activity and let's use set variable one. And let me create two of them. And now this set variable activity, it does exactly what the name suggests. It set some variable to some value. To make it work, I will create new variable called myVar of integer type. So it would be just a number. And here I would configure my activities to set this particular variable to some dummy value, like 1. Because at this moment, I don't care about the business logic, I just want to show you the behavior. All right, so now I've got those two activities, and I want to usually link them to indicate that I want the second activity to be executed after the previous one. And to do this, we've got those various connectors available. We've got 4 of them, those conditional paths. Now, the most common one is the green one called onSuccess, which basically means that the second activity, it will be executed only if the previous one, this one, succeeded. So let me debug it and let's see that in action, how it works. And yes, you can see those green checkboxes, tick marks, that actually both of those activities succeeded. That's great. That's why both of them were executed. Now, let me update the first activity to throw an error. And to do this, I will just try to set my number to a string value, which obviously will fail because it's not possible to convert test string to an integer. And if I try to debug this, obviously the first activity, it fails. You can see this by this red icon. And then the second one was not executed. Why? Simply because we connected them using the onSuccess connector. So that's the first type of connector we could use. Now let me remove it and let's use the second one, onFail or onError. So this one is quite similar to the onSuccess one, but basically it means please execute this activity only if the previous one failed. So let me debug this setup. And yes, and it finished. And what happened? So the first activity failed as expected, but the second one was executed and it was executed successfully. Why the second one was executed? Because we connected them using the onFail connector type, which does exactly this. All right. If in the current setup the first activity would succeed, then the second one would not be executed, would be skipped. Let's take a look at the third connector, onCompletion, which simply means please execute this activity regardless of the output of the previous one. Whether it succeeded or failed, I want this second activity to be executed. So let's see this in action. And yes, the first one failed, but the second one was executed. If we change the behavior of the first activity to succeed, it should work in the same way. The second activity should still be executed because we used this onCompletion connector type. And yes, both of them succeeded. And we've got yet another one called onSkip, the gray one, which basically means that the second activity will be executed only if the previous one was skipped, was not executed at all. And we'll use that in a second in case of some more advanced scenarios. All right. So you saw that we've got those 4 types of conditional paths available, those 4 types of connectors. And also, probably you noticed that every activity, while we are executing it, it has its status. It either succeeded, or it failed, or it was not executed at all. So those 3 states are possible. But what's more is that the pipeline as a whole, it also has its status, which you can see here. The status of the whole pipeline, in our case, was success. And the same was for both activities. They both succeeded, so the whole pipeline succeeded as well. All right, but how this pipeline status is calculated? Well, it's pretty simple. So basically, Data Factory is checking the status of every leaf activity. And let me show you what I mean by leaf activity. So let me do something like this. So now I've got 3 activities, and my leaves are the last ones in the path. So this one and this one. These are my leaves, the last activities in the chain. If I would have something like this, then my leaves would be this one and this one. And to determine the status of the whole pipeline, what ADF does, it is simply checking the status of every leaf activity. And if all of them succeeded, well, then the status of the pipeline is success as well. If any of them failed, then the status of the pipeline is failed. One more thing, there might be cases when one of the leaves is not executed because it was skipped. In such cases, ADF is checking the status of its parent, which in this case would be this activity. If it also was skipped, then it would go backwards through the chain up to the moment where it gets to the activity whose status is set either to a success or a failure. So that's how the status of those pipelines is calculated. And now, having this knowledge, we could start creating some patterns when it comes to error handling in Data Factory. So the first pattern I would like to talk about is simply try catch. Try catch. So how does it look like? Well, very simple. We've got 2 activities. The one that performs some business logic, and if it fails, we want some other activity to be executed. So to make this work, we would simply connect them using this on/fail connector. So let me execute this stuff. So right now, the first activity that contains our business logic, that is here simulated by the set variable, it succeeded. And then the catch block, the error handling one, was skipped because, well, the on/fail condition was not met, right? And the status of the whole pipeline is succeeded. Why? Because the status of the all leaves is set to success. In our case, this is the leaf. We have only one, but because it was skipped, it was not executed, Data Factory checked the status of its parent, which was success. That's why the status of the whole pipeline was succeeded. Now, let me cause a failure in our business logic, and let's see how it would work. And here it works like this. So the first activity failed, and because of its failure, The second activity that handles the error was executed. And it was executed successfully. And because it was the only leaf in our pipeline, then the status of the whole pipeline was succeeded. So basically, we handled the error, whatever it was. So that's the first of our common scenarios or common patterns that we could use. The second one is called do if else. And it's quite similar. So let me add a new activity here. And let me configure it in a way so we could execute it. And simply in this pattern, what we want to do is like this. Please execute our activity that performs some business logic. If it fails, then handle it using this onFail activity. If it succeeded, then perform some other activity. So let's try it out. How does it work? And please take a look. The beginning is basically the same as the last time. So our main activity with the business logic, it failed. That's why the control was transferred to our error handling block that succeeded. But contrary to the previous pattern, this time the status of the pipeline is failed. Why? Because ADF is checking the status of every leaf. And we've got two leaves. This one that was successful, and the second one that was not executed at all, which means that ADF checked status of its parent, this one, but it failed. And because not all leaves or the activities that were checked succeeded, therefore the status of the whole pipeline is failed. So please be aware of this. All right, so this was the second pattern. The next one is called do if skip else. Strange name, but in a second you will see how it is called this way. And by the way, these are the official names of those patterns from Microsoft documentation. I'm not making them up. So it's called do if skip else. Like so. And what changes? Well, we add some dummy activity to our pipeline. I will just use a wait activity, which basically doesn't require any configuration. And I will connect it using this on. Actually, let me remove this and let me show it explicitly. I'm using this gray on skip connector type, like so. And that's it. So how does it work? And let's compare it with the previous pattern. And now what happened? So obviously the first activity failed. We handled the error, but the status of the pipeline is succeeded. The pipeline was successful. In the previous pattern, it was failed status. So why it happened? So here we introduced this dummy activity, which basically it doesn't do anything. It is meant just to be there for the sake of setting this successful status. And why it was executed? Well, because we connected it using this onSkip activity, onSkip connector type. And because this activity was skipped, well, that's why this one was executed. And now Data Factory was checking the status of every leaf, which is this one and this one. Both of them were successful. That's why the status of the whole pipeline was succeeded. And that's how it works. All right, so these are those three basic patterns based on which we could create our error handling logic. But what if we would like to use some more complex scenarios? So actually, let me show you two other cases. So the first one is called try, catch, proceed. And how does it work? So let me remove this activity. Let me remove, actually, this one can be still here. And let me connect this one using on success and on skip, like so. And what's the goal of this pattern? So basically, we want this activity to perform some business logic. If it fails, we want to handle it using this activity, whatever we define there. And then, regardless whether the first activity succeeded or failed, we want to proceed with some other tasks. In this case, we've got this set variable free. So let me execute it and see how it works. All right. So now the first activity failed because we are still trying to convert a string to a number, which is obviously not possible. Then because it failed, we executed the error handling logic in our second activity. And then because this activity succeeded, we proceeded with the remaining activities with our further logic, like this. And status of the whole pipeline is determined by the last activity, by the leaf, which is succeeded. Now, let me change the behavior to eliminate the error, and let's see how it would work in this case. All right, so right now, the first activity succeeded because there was no error. It meant that we didn't have to handle the error in any way, but because we have this on skip connector between the error handling and the remaining activities, the further steps in our pipeline were executed. And the status of the whole pipeline is succeeded. As simple as that. All right, so that was try, catch, proceed. And there is one more pattern I want to show you, which is called generic error handling. Generic error handling. And actually, this one is the pattern that is quite often messed up because developers don't understand how it works. All right, so let me remove those connectors, like so. And let me add a wait activity. And let's assume that it is our error handling routine, whatever we implement there. And it is like this. So let me connect it in the following way. All right. So what's the business goal of this scenario? Well, we've got some activities that in a successful processing should be executed sequentially. They are connected using this onSuccess connector, like so. But if any of them fails, this one, or this one, then we should execute our error handling logic. Or at least that's the intention of a developer. So let's verify whether it works. All right, so the success scenario, it works. All of them were executed successfully. And the status for the pipeline is succeed. Great, so this works. But what if some of the activities in our chain, it fails? Developer expects to execute the error handling activity. But what happens in real life is like this, that the first one succeeded, the second one failed, but the error handling routine is not executed. And that's confusing to the developers. And the status of the pipeline is obviously failed because the leaf, this is the leaf, going back because the previous one was skipped, is a failure. So why this error handling was not executed? And the answer is simple. Because we connected multiple activities to it, those 3 activities, and there is an implicit AND logic between those connectors, which means that to execute this activity, all of those 3 should fail, because there is this AND logic. And simply it is not possible to have all those 3 activities failed, because if this one fails, then the control will be never transferred to the second one. So that's a bad design. It won't work. At least it won't work in the way you think it would work. So how to make it a good pattern? Well, simply do something like this. Connect the last activity in our chain with the error handling logic using onFail connector, and also add onSkip one, like this. And let me execute it, and let's see what happens. All right, so take a look. The first one succeeded, the second one failed, but our error handling routine was executed. And because it was the leaf that succeeded, then the status of the whole pipeline was succeeded as well. All right, but why this error handling activity was executed? Well, simple. This one was skipped due to the connector type we used on success. And because we connected this to using this gray onSkip connector, that's why our error handling was executed. Simple as that. The same would happen if we fail the first activity. This time the first activity will fail, the second and the third one will be skipped, but eventually our error handling routine will be executed. Why? Because this was skipped and this was skipped, right? Now, what if the last one fails? Will it still work? And the answer is yes, it will work. Why? Simply because apart from this onSkip connector, we also have this red onFailure one. And because this one failed, and then our error handling was executed. So one final test is to verify what would happen if all of those our business activities succeed. Will the error handling logic be executed or not? And the answer is no, it won't be executed. So those 3 were executed successfully, and then the error handling logic was skipped, and the status of the whole pipeline is succeeded. So that's the most confusing design I see out there. Developers quite commonly make this mistake. All right, so let's verify if anything changes if we introduce parent-child approach. So it would be something like this. Let's assume that we create 2 pipelines. The first one will be called a child pipeline that would have, 2 activities. And apart from that, we would have a parent pipeline that would have two activities. The first one would be to call the child and then do something else. So basically the logic would be like this, or the flow. When we execute the parent, what we would expect to happen would be like this. Start executing the parent, then go to the child, execute all activities of the child, go back to the parent and execute the remaining activities of the parent. And let's verify what would happen if various parts of the parent or the child fails. So let's go back to our data factory and let's create a new pipeline. And I will call it a child pipeline. And here I would use to set variable activities. I will define a variable of the int type, so it would be quite easy for me to trigger an error. But let's start with a very simple scenario where everything succeeds. And let me create a parent activity, the parent pipeline, sorry. And here I would use as a first activity execute pipeline 1, which basically means please execute some other pipeline, which allows us to modularize our solution and encapsulate some commonly used logic in some pipeline, so then we don't have to repeat it over and over again in every other pipeline. We would just execute the other one. So let me configure it to call our child pipeline, like so. And for simplicity, let's just use await task. All right, let me publish everything. Let me deploy it. And don't worry, in future episodes, I will explain what's the difference between debugging a pipeline and publishing it, when you should do what. All right, so we have it configured, and let me execute the parent using @trigger now option. And now, to see the status of our pipelines, I would go to the monitoring tab, and here under pipeline runs, I can see all pipeline executions. And right now, I can see that both the child and the parent succeeded because, well, there was no error yet included in them. All right, so let's go to the child and let's introduce a bug. Let's fail the first activity. Let me publish it. And let's see what would happen this time when we execute the parent. Will it succeed or will it fail? So again, I'm in the parent and let me execute it. It's running, and in a second we should see the results that actually both pipelines failed. And why? So let's jump into the child pipeline, the one that has the bug. And obviously the first activity failed because we introduced a bug there. The status of the whole pipeline is therefore failed. The logic to determine the pipeline status doesn't change. It's still consistent. It's still the same. And the parent failed as well. Well, because our task to execute a child pipeline, it returned an error, which caused our parent to fail. Simple as that. All right, so let's modify this. So let's go, let's say, to the child and let's handle the error. So let's change the connector type to onFail. And let me publish this stuff. And let's execute the processing one more time and see whether it changes anything. All right, so again, I will execute the parent using add trigger now option. And let's see what will be the status right now. And this time, again, both pipelines succeeded. Why? Well, the child, it had the activity that failed, but we handled the error. We used the onFail connector type, which resulted in the status of the whole pipeline, of the child pipeline, as success. And because it was successful, then the parent succeeded as well. Simple, right? So let's complicate our scenario a bit. Let's remove the error handling in the child. So this child, it should still fail, but let's add an error handling in the parent, like so. So let me repeat what we have right now. So in the child, the first activity will fail because we are trying to convert string to a value. We don't have error handling logic in this activity, but we added an error handling logic in the parent. And did I execute it? No, not yet. So let's trigger the parent and let's see how it will behave. All right, and take a look. This time we've got two different statuses for the child and for the parent. The child failed. Why? Because the first activity failed and we had no error handling logic. That's clear, right? But the parent, well, the task to execute our child pipeline, it failed because the child failed, but we had this onError connector type used that handled the error. And because this is our leaf that succeeded, then the status of the whole pipeline is succeeded. And there is one thing that I don't like in viewing the execution status is that the connector type, it's always black, so we don't see how it was designed originally. And if we verify this in our parent, here we can see that indeed it was on fail or on error connector logic. So these were the patterns and the behavior when we execute pipelines from other pipelines. But the most important part is that the behavior is consistent. ADF is always checking the status of the leaves. And if you know this, then it should be pretty easy to understand what is happening and how you should implement your pipelines to handle the errors in a proper way, according to your business needs. All right, so we know how to handle the error. But what if you would like to be notified if something bad happens? How to do this? And here we've got various options. The first one would be to use alerts. Oops, wrong color. Would be to use alerts that are a part of Data Factory. So how does it work? Well, we have to go into the Monitor tab, the place where we were checking the status of our pipelines. And here at the bottom, we can see this notifications section, which allows us to create alert and metrics. So how does it work? Well, many services in Azure, they generate metrics and logs. And based on those metrics, we can create some alerts. So whenever some condition we defined is met, then we want something to happen. In our case, we'll create a very simple rule of a severity 2, which is medium, I would say. And we've got to define the criteria we want to have to be met in order to trigger our alert. And in our case, right now, we can see various metrics that are provided by Data Factory. And the one that we are interested in right now would be something related to pipeline status. Something called, this one, failed pipeline run metrics, which simply means that some pipeline failed as a whole, right? Remember about the rules of setting the status of the whole pipeline. And here we can select, all right, but which pipelines? Oh, come on, it disappeared because I clicked escape. So I won't be doing the highlighting stuff. Sorry, guys. So again, let me do it one more time. So here we've got to select what pipelines we want to take into consideration when checking whether they failed. And simply, I will use all of them, like so. Then, what type of failure we are interested in? Again, all of them, without going into details what those different types of errors mean. All right. Then, we've got to define the logic of our alert. And the one that is provided out of the box is fine, which basically means that if there is more than 0 pipeline errors detected, then do something. And obviously, we have to define the period over which this condition is to be evaluated. And to make it fast, I will do it over a last minute. So every minute, ADF will check for the status of pipelines, and it will check last minute if there was more than 0 pipeline error, which basically means that every minute it will check if any of the pipelines failed in the previous minute. Like so. In the real life, you probably won't be configured in a way to check it so often, but because I want to trigger this alert very quickly, let's do it this way. All right, so the alert has been configured, and now we have to configure notification part. So what we want to happen when these alert conditions are met. And simply, I will create something called action group and add a type of notification, in case of which I want to be notified by email. Like so. And yes, please create all of those resources and please enable it when we create this stuff. All right, so right now the alert has been created. It's enabled. It works on 5 resources of those 5 pipelines that we have. So actually, let me trigger the parent, because it should fail if I remember correctly, or the child will fail. So let's execute the child as well. And in a minute or two, I should get an email to my mailbox sent from Azure that the alert condition we defined were met, and therefore because I was set as the recipient of the alert, I received some notification. And I can already see some mail. This one right now tells me that actually I was added to this action group. So that's not the alert yet. So let's wait for it for a minute. And let me talk more about this alerting feature. So personally, I am not a fan of this, simply because those emails we receive, they are well, they are not user-friendly. They don't contain too much valuable information, and you will see that in a second. Secondly, those alerts, they are configured outside of our pipelines. We created them here in this notification section, which means that if we use some CI/CD approach to deploy our pipelines on different environments, on dev, UAT, and production, for example, then those alerts and metrics, they are not a part of this pipeline. They are treated separately. So we would have to remember about configuring this stuff on other environments as well. So that's basically why I'm not a fan of this solution. On the other hand, it's super easy to set it up. And it is especially important if you already have some solution implemented in Data Factory. You've got dozens of pipelines, and you want to just start with some alerting mechanism. And you don't want to go over every pipeline and modify it. In this case, this alerting stuff, it might be a good starting point to start with something very quickly, because you should be able to configure these alerts within 30 minutes or so, provided that you have sufficient permissions. All right, so let me wait a second for the email to appear, and I will be back in a second. All right, I'm back, and I can see that I just received an email from this alerting mechanism, which says that yes, my Azure Monitor alert was triggered. It gives me some cryptic information about the role and resource ID that triggered the error. And take a look that, well, it says what actually failed, that my Data Factory failed, but in general, this email is not user-friendly, and there is no way to customize it. Sorry. But it can be set up very easily. All right, so what if you would like to have more control over the email we receive? Is it possible? Sure, it is. But to do this, you would have to create some custom mechanism. And I will use a logic app for this. And now we will talk about logic apps in the future in a more detailed way. For now, just think of it as some software or some application that we want to execute as a response to some action. So that's our logic app, and those things are, this is the icon of the logic app. So basically, why do I want to use a logic app? Simply because Data Factory out of the box, it doesn't have an activity that we could use to send emails. Sorry, there is no such thing. In SSIS, in SQL Server Integration Services, there was such thing, but here it's not. So we have to use some other Azure service to send an email. And logic apps, they work just fine to do this stuff. So let me provision a logic app. And right now, I'm not going into details how it works. Let's just do it very quickly. So let me select a proper resource group. Let me give it a name like ADF mail sender table in West Europe, because that's my region. Let's use a consumption plan, which basically will have an effect that I will pay only for every execution of my logic app. If it is not used, I won't pay for it. So it's a very good thing in my case. All right, So let's create this resource. It should take just a few seconds because it's just an empty thing. We'll configure it in a second. All right. So the logic app has been created, and let me design it. So we've got this nice designer, and basically logic apps are an example of a no-code or low-code applications in which we just drag and drop various things and configure it in a visual way, something similar to ADF. So first I have to select what should trigger my logic app. And we've got pattern or existing template when a HTTP request is received, because that's the one we want to use, because we'll be calling this logic app from ADF. So let's use it. Now we've got to indicate what body is expected by this logic app. And let me copy it from Microsoft documentation like this. And basically we will pass 4 values in the body payload to our logic app, namely what data factory name was used, what is the message we want to send, what was the pipeline name that failed, and to whom we want the email to be sent. That's it. Then we've got to add a step that will be used to send emails. And logic apps have a lot of connectors defined, available, that we could use to execute various operations. So for example, it has a connector to Outlook that will allow me to send an email, like so. So now what action from this Office 365 task I want to use? We've got many available, but I want just to send an email. So let me find it. Send an email, this one. All right. Now, to be able to send emails from Office 365, I have to create a connection. So the logic app would know as whom I want this connection to be made. And I will do a bad practice here because I will use my own personal account. So the emails will be sent as me. Oh, come on, sign in, please. Browser is closed. Why is it closed? Yes, please. You know what? Let me pause and let me fix this error, and I will be back in a second. All right, I am back. I am not sure what was happening in the Firefox, so I changed the browser to Edge, and here I was able to create this connection. But as I said, I did it in a not the best way because I used my personal account, which means that now this logic app will be able to send emails as me. It will be able to impersonate me. So anyone who will use this logic app will be able to send emails as me. So in real life, in real projects, I would advise you to create some dedicated account just for sending emails. All right. So let's configure our send mail operation. So first, let's indicate to whom we want the email to be sent. And well, we have those parameters available that we defined in the request payload. And it was called receiver. So let's use it. Then the subject of the email, let's create it as message from, and use this data factory name value that we receive, and then pipeline what pipeline failed, this one, the value that we receive as a parameter to our logic app. Then as a body of the message, of the email, let's use the message parameter. All right, and that's it. So let me save my logic app. Let me grab its URL, this one, because this is the way, this is the address to which we'll have to send a request to trigger our pipeline. So let me copy it, and that's it. So let's go to Data Factory, and let me add this step to call a logic app if something happens. All right. So let's use the child pipeline. Is it still causing an error? Yes. All right. So how to call a logic app? Well, yeah, let's use a different type of activity, this web activity, which allows us to, well, send a web request to some address. I will connect it using onFail connector type. Let me call it send mail, and let's configure this activity. So first of all, we've got to define to which address we want to send the request. And I've just copied it to the clipboard. So that's it. Then what method should be used? And in this case, I know it has to be a post. And then we've got to provide a body of our request. And here, let me just copy the sample body. And it's like this. It's a JSON that contains various fields. So we've got this message part. This is the custom dynamic message from pipeline with run ID. And please note that we are using here system variable pipeline run ID, which is available here. That's the identifier of the pipeline run. Oh, come on. The same with Data Factory with the pipeline name. And apart from that, I'm using a parameter called receiver. So that's the email recipient. Right now, this parameter doesn't exist yet. That's why we have this red squiggly line. So let me add this receiver parameter to my pipeline. So let it be a string type, and let me provide a default value. Like so. And let me publish this pipeline. And now, when we execute this, what should happen is that the pipeline should fail, the first activity should fail, and as an on-error action, we should execute our logic app that was executed. That should send an email to my account with some error information. So actually, let me log into my mailbox to see whether this thing will be there. Oh, come on, not this account, this one. And yes, take a look. We've got new email that was just received. Message from name of our data factory. Then the pipeline name that failed. So these were the dynamic values set at runtime. And then the content. This is a dynamic message, and we've got the run ID that failed. So this value will help me to identify the failed instance of the pipeline. And obviously the recipient, me, was also dynamic. And now, when we use logic apps to send those emails, we have full control over the layout of the email. It's up to us to define how we want it to look like. Do we want to have some tables, some links, whatever is important in our case. So that's a way to have more customized error handling routines than the ones that are available if we use just an alerting system. But the point is that to be able to use it, we would have to add it to every pipeline that should contain this error handling logic. And now, if you want to follow along and practice this stuff, I would suggest to do such exercise. Please create a new pipeline, some generic error handler that would be used to execute a logic app to send the email with some information. This pipeline should expose various parameters like receiver, pipeline name, pipeline run ID, data factory name, and then modify some existing pipeline, for example, the one that we used to dynamically ingest data from SQL Server, SQL database, and then add this error handling logic, and then call this error handling pipeline, passing all required parameters. And now, if you have this generic pipeline that contains all the steps that you usually do in case of errors, then it would be very simple to reuse it in other places. You would just have to call this pipeline. And if one day you would like to modify your error handling steps, then you would have to do it in one place only, instead of in every pipeline. So that's how you could do this. All right, there's one more thing I want to talk about. Basically, the logs. So, oh, come on. Those logs, those execution pipeline logs that we can see here, well, by default, they are stored only for 45 days. You can see that I cannot even select the date that is older than 45 days. In many cases, this is enough when you just want to monitor your execution on a daily basis. But what if actually you would like to store your logs for a longer period? Maybe you're interested in checking the performance month by month to see that maybe the time it takes to execute your pipeline, it is constantly growing due to the increasing amount of data you have to process. And if you would just take a look at the data that is stored for 45 days, it might be too short time period to spot some patterns. So how to make sure that our logs are stored for a longer period? And this is where diagnostic settings can be used. Diagnostic settings. So how to do this? So basically it works like this. So we've got our data factory, and by default our logs are stored only for 45 days. But what if you would like to keep it for a longer period? Well, in such case, we could use a different service that is called Log Analytics Workspace. Log Analytics Workspace. And to do this, we'll provision this new Log Analytics Workspace service, and we'll configure our data factory to send various logs to it. And now, in this Log Analytics Workspace, we can define time period for which we want these logs to be stored, even for 2 years. So let me start deploying this service, and then let me configure it. And then we'll get back to talking what we could do with those logs. All right, so let's provision a new log analytics workspace. And let me create it in a proper resource group. Demo log analytics workspace in West Europe. And let's create this. Yes, please. All right, this service should be again created within a minute or two. So basically in Azure, it is very fast to create various resources. There are some exceptions. There are some services that takes hours to provision, but in this case, it is very fast. You see, it's already deployed. Right now, it is empty. There are no logs stored yet. So let's go to Data Factory and let's configure those diagnostic settings. To do this, I have to go out from the Data Factory Studio where we create our pipelines and go to the Data Factory resource. And here, under Monitoring tab, you could see this Diagnostics Settings option. And here, let me add new settings. Let's give it a name, Diag Settings. And here I can define what type of logs I want to be saved in a log analytics workspace. To simplify, I'll just send all logs. And here I can define the destination of our logs. We've got 4 different types, but the one that I want to use right now is the log analytics workspace. And yes, I want to send it to my demo log analytics workspace, the one that we've just created. And yes, save it. So it means that from now on, Data Factory will start sending those logs to this log analytics workspace. So actually, let me execute some pipelines just to have some data available. Like so. Maybe even this pipeline. No matter what it did, it's not important in this moment. All right. And now please be aware that it will take at least a few minutes for logs to be available in the log analytics workspace. And if we go to this log analytics workspace, then here under usage and estimated costs, we can define data retention, which means simply for how long we want these logs, this data, to be stored. By default, it is set to only 30 days, which is even less than the default settings in the Data Factory. But we can set it to 2 years basically. But let's keep it simple to 30 days for the purpose of this demo. All right, so we have this. So the data, those logs, will be available not only in Data Factory under this Monitoring tab, but also in Log Analytics workspace. All right, but so what? What can we do with this? So basically, a Log Analytics workspace is a place to which we will send logs from various Azure services. That's the common place that gathers logs. And those logs can be queried in a very efficient, very fast way using something called Custom Query Language, KQL. I'm not going to teach you about the syntax of this language. Just please note that it is extremely powerful language that is able to do magic with the logs. Extracting, parsing the logs is very simple and very effective. So let's say that our data, our logs are already available in the workspace. So what we could do with it? Well, first, what we could do is to create something called a workbook. And workbook is just a combination of text and those KQL queries available on a single page. And as a result, what we could have is some kind of diagrams, let's say, that show execution time of our pipelines, or how many errors there were on a given day. It could show the status of our various environments in a single place, like dev, UAT, and prod. It might contain some text that, for example, explains what those various charts, various tables mean. So basically, it might be your dashboard, some kind of a report, and that you could use to see the status of your whole data factory environment. And not only data factory, because if you configure Azure and different services to send logs to the same log analytics workspace, well, you could use those logs as well. Great, but what if you would like to have some automatic notifications created? Well, here we would use again a logic app. And you can see already that logic apps, they have a lot of use cases in data engineering. So what we could do is again create a logic app, but this one would use a different type of a trigger. So no longer it would be triggered from a data factory. No, here we would use a time-based trigger. So let's say every hour or every day or every 6 hours, whatever schedule works for you, this logic app will query our log analytics workspace and look for errors, pipeline errors, activity errors, or whatever works in your case. And then if some strange situation is detected, maybe some pipeline failed, what this logic app would do would be simply, well, send an email to someone with some details about what happened. And again, because this is a logic app where we have full control over the layout of our message, we can do everything in it. We can even include the error message. So let me check if some logs are already available, and I will show you how it looks like. So let me go to workbooks. I'm in the log analytics workspace. Let's use a quick start template just to show you how it works. So basically, that's the place where you can define your KQL query. And let me make sure that I'm connected to the proper log analytics workspace. Yes, that's the one that we just created. And the table in this workspace that stores pipelines logs is called ADF something. All right, it's not populated yet. So let me pause here, and I will be back in a minute or two once those logs are available. And then I will show you how they look like. All right, I am back. The data has been populated in Log Analytics workspace, and actually we can see all those new tables that were available from Data Factory. To see them, you can go into Tables under Settings, and here you can see all these ADF something tables that are the tables that contain data sent from Data Factory. All right, so let's go into the workbook. And actually, let's start with one of those activities, one of those tables. It was ADF activity run or runs run. So right now, my query just listed all data that is available in this table. And take a note that we see all data related to every execution of every activity, including, let's say, the status. So we can easily filter those activities that failed. So to do this, let's use this KQL language and use where filter, where status equals to failed. So right now I will see only those activities that failed. Great. So I can see all the information that I could use to correlate given activity with specific pipeline by using this pipeline run ID. And I can also see the actual error. Why given activity failed. For example, in this case, well, it was simply the error that we caused when we tried to cast a string to an int. The same way, we can take a look at pipelines. So not only at single activities, but at pipeline as a whole, like so. And here I can see two pipelines that failed. And again, based on this data, I could write a KQL query that would be executed by my log analytics workspace, grab the data, and then send a customized email with all details that are required. All right, and that's it. So to summarize, in Data Factory, we've got various ways to handle errors and to monitor executions of our pipelines. So the bare minimum you should use is to set up retry logic, just by using those built-in capabilities. Apart from that, you can use those various connectors, conditional paths, like on success, on fail, on skip, and on completion, to implement those various patterns used to handle errors. Apart from that, if you want to start quickly with notifications, you could turn on alerting. But the drawback is that it would use those fixed email layout. If you would like to customize it, you could create your own logic app that, for example, you could embed into a dedicated pipeline. Then you would call from all your pipelines. Or if you would like to have a more general solution that doesn't require changes inside your data factory, then you could use a log analytics workspace and a logic app that queries those logs and then send emails. And this log analytics workspace with diagnostic settings configured is also useful when you want to have those logs available for longer period than 45 days. And that's it for today. I hope it was useful. Please practice this stuff in action. Try to cause some issues, some errors, and then handle it. And that's it. Thanks for watching and see you next time. Take care.